Text: Smithsonian National Museum of Natural History. Curious, unlock your world. Smithsonian, Science How, behind the scenes.
Thanks for staying curious. You're watching Smithsonian Science How Behind the Scenes with Smithsonian geologist Ben Andrews.
Ben stands behind a table with 7 rock samples resting on its blue cloth. A backdrop on the wall behind him depicts a snowy mountain scene.
Hi, my name is Ben Andrews, and I'm a scientist with the Smithsonian Institution National Museum of Natural History. I'm here today to talk with you about the 3 types of rocks that cover the Earth's surface. Those types of rocks are igneous, sedimentary, and metamorphic. We're going to begin here by looking at a few igneous rocks.
Ben gestures to the 4 rock samples on the right. They consist of a cube-shaped rock mottled with gray and black, a small, jagged jet black rock, a chalky white rock, and a large, glossy rock with a dark maroon color.
All igneous rocks begin as molten rock or magma, and sometimes they don't crystallize at all. When there's no crystals formed, we get a rock like an obsidian right here, which at this time is just a big piece of glass.
Ben points to the obsidian, the big glossy maroon sample. It has striations of red and black coloring all over its shiny surface.
Now if we let bubbles form in that rock, we could get a pumice, like this white rock here. This pumice is entirely glass, but it also has about 75% bubbles in it.
Ben gestures to the pumice, the chalky white rock. Text: pumice equals glass plus bubble 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 bubble. The word bubble appears in different places on the rock's surface.
Now if we let a rock crystallize all the way, we can get a rock like a granite right here.
Ben touches the granite, the mottled cube. It has one smooth, shiny face pointing outward and rough jagged faces adjacent to the shiny one. It has splotches of white, gray, black, and beige coloring.
The difference between this granite, this pumice, and this obsidian has nothing to do with composition, but has everything to do with whether there are crystals and whether there are bubbles.
The granite appears, then the pumice.
If a magma crystallizes below the surface as an intrusive rock, we get a granite, whereas if it erupts as a lava, we can get an obsidian, or if it explodes, we can get a pumice. Now the other type of igneous rock that we have up here are basalt lava and pumice. We see that right here with the Pahoehoe lava, and right here with a couple of pieces of basalt pumice, or basalt scoria.
To the left of the granite sits a large black sample with fluidly shaped folds in its surface. Text: Pahoehoe lava. Then, Ben gestures to the small jagged sample between the granite and pumice. It is black with small shiny flecks that glitter. Text: basalt pumice.
Our next type of rock is a sedimentary rock. And we have that right here with this beautiful laminated sandstone. Now sedimentary rocks can ultimately be made in a couple different ways.
To the left of the lava sits a sandstone sample. It has one large, smooth face, covered in fine, thin stripes. The stone is a gray-beige color with stripes in a darker shade. Text: layer by layer by layer by layer.
One way is through the layer by layer deposition of pieces of other rocks, and that's what we have here. There's about 40 or 50 different layers of sand in this sandstone, and each one of those is made up of little tiny pieces of sand or of other rock. The other way that we can form sedimentary rocks is through the chemical precipitation of things like a limestone. And often in sedimentary rocks, we also find fossils. Our last type of rock today are metamorphic rocks. And on the end of the table here, we have a gneiss, that's spelled G-N-E-I-S-S, and this is a rock that's been totally recrystallized.
The gneiss sample has a smooth, glossy face with an irregular shape. It has jagged, zigzagging stripes in white and black, and splotches of rusty brown.
So it did not melt, but it was taken to such extreme pressures and temperatures that all of the individual minerals and bits and pieces of this rock reformed into new mineral grains. And we can also see that this rock has some amazing folding in it. That's because most metamorphic rocks are getting squished and smushed as well as cooked.
An illustration shows stripes of different widths stretching between 2 surfaces. The 2 surfaces press closer together, squishing the stripes and causing them to form squiggly, folded shapes. Text: L squish, smash, cook.
And that's why we have that amazing series of folds and wiggly, squiggly lines there. Thank you very much.
Text: curious.si.edu. Smithsonian National Museum of Natural History. Copyright 2018 Smithsonian Institution.